Chelsea would not be the name of my cat. My cat would be named Whiskers or Mittens. One or the other. Both names are good. But our cat here is named Chelsea. So Chelsea the cat here is pulling a mouse from Unit 6 by the tail. And Chelsea's making a 40-degree angle with the wall here. The mouse has a weight of 3.2 newtons, and Chelsea's pulling with 15.5 newtons to overcome the force of the resisting mouse. She drags the mouse to her dish, which is 2.6 meters away, and she does it in 4.6 seconds. So in part A, how much work does Chelsea do? Well, we know from the last problem and from our previous videos that work is equal to a force dotted with a displacement, which, if you recall, that dot product really means a cosine component, or a force parallel to the displacement here. And if we look at what we have, Chelsea's pulling with 15.5 newtons of force. Don't be confused and use the mouse's weight. That's not anything that belongs here. The delta x is how far she's pulled it to the dish, 2.6 meters away. That gives us Newton meters, that's joules. But then our cosine term comes in, and we need the angle. Now, rookies, or people trying to do physics for the first time, will often just put whatever angle is given to us in the problem, but that wouldn't be good. What we want here is we want the angle between the force and the displacement vector. And if we draw this out, Chelsea's pulling up like this, the mouse is moving to the right. That means we want this angle between the force and the displacement. We don't have that though. All we know is that this angle up here is 40 degrees. But that's fine by us because we've done things like this before. We know that this is a right angle here of 90 degrees. And if we take 40 off of 90, so 90 minus 40, that gives us the leftover of 50 degrees right here. And that's what we actually want. That is the component of the force vector acting in the direction of the displacement. So if we take all this together and multiply it, because Chelsea can't do that herself, she's just a cat. Make sure that you're in degrees if you're using degrees. We find that the work done by Chelsea the cat is just about 26 Newton meters, which we can write as joules. In part B, we're just trying to look at how much power has Chelsea exerted here. We know power is a work divided by time. We know the work she's exerted, 26 joules, and we know the time here, 4.6 seconds. Joules in seconds are proper SI units, which is really nice for us. So 26 divided by 4.6 just gives us a quick 5.7. And then we could either write this as joules per second, or we could just put a W and call it watts. And that's it. This problem's now finished. Nothing too crazy there. Just a quick little work problem and a little bit of power. Once again, the big things on these problems are redrawing pictures for your forces and displacements so you can get that angle right, and recognizing that you're looking for a force, not a weight, when entering it into that work equation. Okay? When we look at some future videos, we'll start looking at mechanical advantage coming up shortly. But until next time, adios, and take it easy.